In this video, we'll be starting with discussion of answers for the first module. So if you have not watched my previous video, I have uploaded all the important questions there. I have discussed it there. So do watch that video. So in the first module, the first question is define database, or they can ask database management system. And along with that, we need to explain the characteristics. So this could be asked for 4 or 5 marks. So a definition of database, it basically means to the collection of data. So you take some aspect of real world and then you make use of it to perform various operations. So that's what some aspect of real world is called as mini world. So the changes made to mini world are reflected in the database. So it is logically coherent collection of data. So this is pretty easy definition. Moving on to DBMS. DBMS is collections of programs that enable user to create, maintain the database. Maintain the database. So it is a general purpose software that facilitates process of defining, constructing, manipulating, and sharing of data. So defining means you're defining whatever the data you have obtained from the mini world, you're defining it here, right? So it is defined and stored in the database catalog. It's called as metadata. And then constructing. So the process of constructing or the process of storing data is constructing here. Manipulating. So you write different queries to obtain the information, right? So that's what deals with manipulating. And then sharing. So as we know that DBMS database management system has an advantage, that is multiple users. It can deal with multiple users and programs and provide access to them. So looking at the simple database system environment, so we have a user program and then the application program, that is user gives queries as the input. So these queries are taken to the software, they are processed, and further there is a software to access the data from the database or from the metadata also. So once the data is accessed, it is further provided to the user as output. So this was about definition of database and characteristics of database. Moving on to, so here we have the characteristics. So first is the self-describing nature of database management system, a database system. So database includes a complete description of its structure and constraints that are stored in the catalog. So if you use DESC command, so you'll get to know what are the constraints used, what is the structure of that particular table, right? So that's what here self-describing nature refers to. And then the second point is it creates insulation between programs, data, and data abstraction. So programs accessing the data are independent of its structure, allowing changes without modifying the programs. And data abstraction is also like the user cannot have complete insight of the data, only the queries whichever he gives would be reflected. So that's what data and data abstraction here would define. And then we have support of multiple views. So depending on who the user is, there would be multiple views provided. So we'll discuss about different users in the next question. Then we have sharing of data and multi-user transaction processing. It's the same. So multi-user databases allow simultaneous access with concurrency control, ensuring that data integrity is maintained during the updates. So transactions ensure correctness and efficiency. So this was about characteristics of database. Now we'll look into the advantages of database over the old traditional file systems. So first one is it controls redundancy. So by the normalization method, we can minimize the duplicate tables and ensure that the consistency is maintained along with storage of space. Then coming to the second point, it enhances security. So it provides access control, allowing only authorized users on the basis of their roles and permissions. Then we have persistent storage for program. So object-oriented database facilitates storing complex runtime objects which are compatible with languages like C++ and Java. So from C++ and Java, you can make use of the commands to obtain the data from the database, right? So that's what this means. Then we have improved query efficiency. So the efficiency of generating the outputs is improved here compared to the traditional one. Then we have data recovery. So yeah, even after the failures, if the system gets shut off like accidentally or all of a sudden, the data would be backup would be there. It would be provided in disk backups. So that's what about that is what ensures data recovery says about. Then we have multi-user interface. We have discussed this. Then it manages complex relationships. So it can handle intricate data relationships, ensuring easy retrieval and updates of data, enforce data integrity. So by the implementation of data type constraints, referential integrity, and uniqueness constraints, we can maintain the integrity. And then we have supports interfacing and rules. So there are different interfaces which provide compatibility to the database. So here even the triggers are being used. This was about the advantages of using database. Next we have the database interfaces. So there are different interfaces. Interfaces what you see on the screen. So depending on the user, the interfaces vary here. So for the first one is menu based. So like if you in a menu based interface, you'll have all the items or menu options would be provided with for query formulation, eliminating syntax memorization. Then you have form based like Google Forms, and then you have GUI pointing devices. So GUI, graphical user interface, in that we make use of pointing devices to manipulate the data by querying. Then we have natural language interface. So even if you give the input in terms of human understandable language, it converts it to high level queries. Then we have speech input and speech output. So natural language processing here again. So interacts via speech for limited vocabulary applications. Then we have interfaces for parametric users. So for general users, so it offers single function keys for routine transactions. Then we have interfaces for DBA, database administrator. So because they have to deal with complex programs or complex, their job is to design the database, right? So depending on their work, the interface is also different for them. So this was about DBMS interfaces. Here we have database users. So there could be different users for the different users accessing the database. So let's see one by one. So first is database administrator. So as we have discussed, database administrator manages that entire database system. So he or she will look into the user's access, ensure system integrity and performance. Then we have database designers who design the front end and the back end part of database. So that's about database users, database designers. Then we have the casual users, so who occasionally access the data using normal queries. Then we have the naive or parametric. So these users have a standard set of functions to be performed. For example, a bank accountant, so he or she has a standard set of operations, that is to check the accounts or deposits. So they use only specific queries for that purpose. Then we have the sophisticated users. So the ones who are familiarized with the complex database queries and complex topics can make use of could be considered under sophisticated users. Then we have standalone. So in standalone, they maintain a personal database using user-friendly software packages. Then we have system analysts and application programmers. So here it's main about development and testing. Then we have workers behind the scenes. So they are tool developers and operators. So they are the ones who deal with creation and development and management of the entire database. Moving on to the next topic, here we have the 3 schema architecture. So if you look at the top, here we have the external view, then we have conceptual view, and then here we have the internal schema. External schema, conceptual schema, and internal schema, and here is the database. So you can understand 3 schema architecture. So there are 3 schemas here. So the first schema is the internal level. So it describes physical storage, yes, and the structure using physical database model. So yeah, it's about internal schema. Then coming to conceptual, it hides the physical storage details. It describes the entire database structure. It focuses on entities, relationship constraints using representational database model. Then coming to the topmost part, here we have the external view, external or the view level. So it has external schemas for specific user groups only. So it describes only relevant part of database, hiding the rest. So the process of transforming requests from one level, one schema to another schema is called as mapping. So this was, I have tried to explain 3 schema architecture in a pretty simple way. So this was about it. Next we have the database management conceptual model. So here we have different types of users. So it could be database administrator staff or casual users or application programmers or parametric user. So database DBA staff gives the input in form of DDL commands, data definition language statements, which is further loaded in the DDL compiler. Whereas if privileged commands are given, they are transformed to the runtime processor. Coming to the casual users, they make use of normal interactive queries, which is further sent to the query compiler and then to the query optimizer and then further to the processor. Coming to application programmers, they write the program, then it goes to the pre-compiler where the host language compilation process is done. Then the compiled transactions are further sent to the processor. So once all these are obtained from the processor, it is further sent to the storage data manager where the important operations take place. From there, it is again transferred to the stored database. So here we have the system catalog. We have discussed what system catalog is in the previous question, right, in the starting. So here we have to, once you draw the diagram, you need to explain all the important components. So first we have DDL compiler. So it processes the schema definition, stores metadata in catalog, which describes the structure of database. Coming to interactive query language. So as the casual user gives the input, so the queries need to be compiled, right? Compiled and optimized and then sent to the processor. Coming to query compiler, yeah, it compiles. Query optimizer optimizes. Then we have pre-compiler. So in case of application programmers, so the extraction of DML commands from application programs is done in pre-compiler and then we prepare them for compilation and execution by the database system. Then we have host language compiler. So it handles non-database program parts, integrating them with DML commands. From DML commands, it is passed on to the further process. Okay, then we have the runtime processor here. So runtime processor executes the commands, query plans and canned instructions. So it also interacts with the database catalog and stores the data and stored in the stored database manager. Coming to what stored database manager is, so it manages low level input output operations. And then we have concurrency control and backup / recovery systems. So in order to establish the smooth flow of data, we need to make sure that the security and concurrency is controlled in the database, right? So that's what is handled by this component. Next, moving on to the next topic, we have centralized and client server architecture. So in centralized DMS architecture, we have like everything would be concealed in one box. So definition, let's see the definition. All database functionalities, program execution, user interface, processing are carried out in one machine. So that's what it is. So here we have the terminals. So display monitors, n number of display monitors which are connected to the software. From software we have the operating system, followed by that we have the software and software only. So operating system part where system bus, CPU, memory, all those are there. So so the disadvantage for this is if the central computer fails, everyone is blocked from using the system, and because we have to connect everything, so it might be costly. So the terminal central computer connection is expensive. So this was about centralized DBMS architecture. Now we'll look into client server architecture. So by the definition, we can understand that there'll be a client and server. So it was developed to deal with computation environments in which large number of PCs or printers and software equipments are connected in network. So the idea is to define specialized servers with specific functionalities. For example, a file server maintains the file operations and client machines. files of client machines. Coming to the specialized servers offer resources accessible by multiple client machines. Then we have the client interface here. So in client interface, user utilizes server resources via client interface and logical processing. So user makes use of client interface in order to access the network connection network, right? Then we have the logical and physical. So these are the two tiers in the architecture, right? Two levels. So it represents client server relationship logically and physical setup. So client provides user interface and logical processing capabilities. Server delivers the services. And the framework here is the system, the entire system, which is connected via LAN or any other network. So this is the diagram for both. Coming to object-oriented DBMS. So the ODBC and JDBC. So these are the interfaces, the standard interfaces which are used to connect the database by using the programming languages. So APIs are used for connection of program to program using standard interfaces. Coming to integrated division, so software modules are divided between client and server properly. So then coming to the server functions and client functions, they are the same as we have discussed above. And then all these are tightly coupled interactions. So they make sure that there are no errors happening. So that was about client server architecture. Moving on to the next, we have a three-tier architecture for web applications. So many web applications use this architecture between the client and database layer. We have application layer. So that's about three-tier. In the two-tier, we had client and server, but then here we have application server or web server also. So client server, client is also called as a presentation layer. A database server is called as the database services layer. Application server, web server is called as business logic layer. So client contains the GUI interfaces and web specific business rules which are forwarded to the application server. So it accepts the client request, processes them, sends queries, forward packets, and processes the data back to the clients. Then we have the database server in which all the data is stored. So by using the application server, we retrieve the information whichever is required and then present it back to the client. So that was about database server. Now discussing about high-level conceptual data model for database design. So this is the systematic approach of designing a database. So first we have from the mini world, we'll collect all the required information and then perform analysis. So it's about data requirements. Then we form a conceptual model to that. Further, we look into the logical aspect. That's what designing the logical design means. Then we'll deal with the physical design. Once it is done, it is then sent to the transaction implementation from which it is forwarded to the application programs. So now we'll look into the explanation of that. So first we have requirements collection and analysis phase. So in this, database designers interact with the users to understand what their requirements are, so that depending on the requirements, the database model could be built. Then we have the conceptual model. So once the requirements are clear, so we make use of high-level conceptual data model here. So to describe the entity types, relationships, and constraints for building the model. Once all these are described, we make use of the logical design where we implement the database schema, where we design the database schema. So that was about logical design. Then coming to physical design, it is to specify the internal storage structure, file organization, indexes, or physical design parameters. So this was about high-level conceptual data model for database design. This could be asked for 6 marks or 8 marks. Next we have types of attributes. So attributes are a particular property that describes an entity. So here we have 5 types of attributes. So the first one is composite attributes versus the atomic attributes. Composite attributes are the attributes which have which could be further divided into smaller parts. So like this. Whereas atomic attributes, they can't be further divided. Coming to the single valued and multi-valued, you can understand it by the definition itself. Then coming to stored attributes and derived attributes, the ones which are derived from other attributes are called derived. The ones which cannot be derived are called stored attributes. Okay, we need to write example for this. So for composite, you can make use of a business schema. Business schema is further divided into many subparts, right? Whereas if you look at the simple attribute, you can make use of student USN, which is simple, right? For one student, there is one USN. Coming to single valued, multi-valued, you can write stored and derived. This is also easy. You can write null valued. So absence of values for that attribute. So we make use, they are used when particular entity may not have appropriate value for that attribute at that particular time. So either the values are not known, or they are not compatible with that particular constraint, or they are kept blank but would be filled in the future. So that's what null value in general means in database management system topic. Coming to complex, they are built using multi-valued and composite. So if you make use of attributes which are built using multi-valued attributes and composite attributes, it refers to complex attributes. Then coming to the next topic, here we have, okay, this is pretty important because it could be asked for 1 mark. So there are many definitions. So they can be asked for 1-2 marks, or they can give five topics and then ask us to write the definitions with an example. So let's start with the first one, entity. So entity is collection of things. So it could be a thing in a real world which is independent of its existence. So existence here could be physical or conceptual existence. Describing about entity type. So a set of entities having same attribute are called as entity, come under entity type. So it is described by name and attributes in the database. Then we have the entity set. So the collection of all entities of particular entity type in database at any point in time. So it is represented using ER diagram. What is ER diagram? ER diagram is also called as ER schema. So it describes the entity relationship model, or the virtual representation of data model that describes the structure of database. Then we have the canned instructions. So they are predefined or packed set of instructions, database operations, which are executed as one single unit to perform common task or operation. Then coming to cardinality ratio, so it is the ratio between one entity to the another entity. So it could be 1:1, one to many, many to many, or many to one. Then we have participation constraints. So it tells us the degree to which entities are required to participate in a relationship. So it could be total participation or partial participation. Then we have a weak entity type. So entity that lacks a primary key on its own. So it depends on another entity. So here it could be the entity which has the primary key would be the owner, and then this weak entity would be it comes under that. So that's about weak entity. So in order to identify weak entity, you need to make use of the owner entity's primary key. Then we have the structural constraints of a relationship. So if you combine the cardinality ratio and the participation constraints, you get the structural constraints of a relationship. So this was about a first module. I would suggest you to go through these topics thoroughly, and then do have a look in the PDF also. There are a few topics which I have not covered, which are not that important, but then they might ask an exam. So by comparing previous year papers and sim questions, these are the important questions which I was able to identify. So yeah guys, for in the upcoming videos, I'll be uploading answers for all the other modules also. So stay tuned to my channel and subscribe. Thank you.